Hi, in this video, contents related to UAV calibration procedures will be shared. For unmanned aerial vehicles to fly accurately and safely, it's important to precisely adjust their sensors to the desired values, meaning calibrating the parts of UAV that require calibration. UAVs have various sensors to determine their position, maintain balance, and perform flight tasks. The proper functioning of the sensors, such as compass, EMU, GPS, barometer, gimbal, camera, and optical flow sensors, are critical for drone to achieve stable and safe flight. The calibration process optimizes flight performance by verifying that the sensor's measurement values match the desired values. This allows the drones to perform more precise maneuvers, follow the desired route more accurately, and land more safely. Compass calibration is crucial for drone to determine its direction accurately. EMU calibration ensures the proper functioning of sensors like accelerometer and gyroscope, which maintain the drone's balance. The user manual of commercially produced drones explain how to calibrate the compass, EMU, GPS, controller, and gimbal. Additionally, all calibration can be performed by following the instruction on drone's application. Some drones may indicate the need for compass calibration through their light system via application or flight control surface. Compass calibration should perform before flight when changing in flight area or after long distance travel with your drone. When calibrating your compass, it's important to stay away from metal objects, sources of electromagnetic interference. It is more suitable to perform it in an open area. Access the compass calibration function from your application or controller. Start the calibrating processes. Hold the drone horizontally and rotate it 360 degrees. Then hold the drone vertically, its nose pointing down, and rotate it 360 degrees again. If your model requires it, repeat the same process with nose pointing up. Ensure that calibration is confirmed. You can verify this through the application by checking the color and blinking patterns of lights on drone. EMU calibration requires a bit more process compared to compass calibration. For EMU calibration, place the drone on a flat surface and access the calibration menu in the application or control device. Select the EMU calibration and keep the drone steady during the processes. Follow the drone application instruction to complete the calibration by rotating the drone in different directions and confirm that the calibration is successfully completed. For flight control calibration, open the support interface of DJI Fly or DJI Go applications. If using ArduPilot, connect the drone with the mission planner application. For example, in DJI drones, after turning on controller, go to the control setting menu, click on controller calibration option, and follow on-screen instruction to move the control stick completely calibration process. In Mission Planner application, select the mandatory settings section in the setup tab. Choose the control calibration from menu that opens. Follow the instruction in application to move the control sticks and complete the calibration. In mini drones, barometer automatically calibrates itself by accepting the current altitudes as 0 each time drone is powered on. For larger drone, ensure that drone is in room temperature and oriented away from air currents. For barometer calibration is performed in windy conditions, should be repeated on a calm day. Access calibration function and keep the drone steady during the processes. Barometer calibration is usually an automatic and quick process, but confirmation of successful calibrating is required before flying. For gimbal calibration, place the drone on surface parallel to the ground and access gimbal function. Ensure that gimbal's movement is not obstructed and the gimbal will move left, right, up and down through its range of motion. Once calibration is complete, monitor the gimbal's performance on UAV, and if the issue persists, repeat the calibration. Camera calibration is necessary to address physical operational issues that may affect UAV's performance. For example, calibration is important when UAV experiences a hard landing or impact. Camera suffers the physical damage or a deterioration and image quality is noticed. When visual and functional indicators should be considered to determine the need for calibration. Visual indicators include blur image, distorted color balance, edge distortions, and focusing issues. Functional indicators include autofocus problems, image stabilization issues, and GPS position matching error. When such symptoms are detected, device calibration needs to be renewed. The calibration of optical flow sensor: choose a well-lit area with textured surface. Access the calibration function and hold the drone at about half meter height, slowly moving the drone according to instruction provided by application. Altitude consistency should also maintain during the process. As with all calibration, the process is complete once device display a calibration successfully completed message. UAV technicians and operators should perform calibration procedures at regular intervals as needed. Compass calibration is recommended before each flight, although there is no issues as long as UAV application do not indicate a calibration warning. EMU calibration should perform before the first flight and after any crash. If there is inconsistency between stick movement on flight controller and drone's movement, calibration should be performed. The barometer is usually calibrated at infrequent intervals in calm weather. The gimbal should be checked after transportation or if there is tilt in the video images. The camera is rarely calibrated unless there is no drop in image quality. The optical flow sensor should be calibrated when obstacle detection performance decreases. GPS is rarely calibrated unless there is an issue. Calibration is mandatory when a new GPS module is installed. After structural changes on UAV, follow significant impacts or crashes when inconsistency in GPS signals are detected. GPS calibration is generally not a user-performed process. It is often done automatically by system designer or firmware developers. Post-calibration checks are very important. First, verify that calibration was successful through application or controller. Then conduct a short test flight in a safe area to check the accuracy of sensor readings. If the sensor persists, repeat the calibration, and if the problem is not resolved despite repeated calibrations, ask for support from manufacturer. In this section, we covered UAV calibration procedures. I hope the contents have been helpful. See you in next content. Goodbye.